Some say the science of chemistry dates way back to the ancient times, when people grew fascinated by the ways different objects reacted to burning. Alchemy was thus born, though it failed to properly explain the transformation between states of matter, and so failed to progress further. It eventually evolved into modern chemistry. Chemistry is called the central science and has 5 main branches: analytical, inorganic, organic, physical, and theoretical. People who solve problems for our planet and its living beings by using chemical knowledge and apparatus are called chemists. Joe was a doctoral student of Chi Ming and joined this research team 7 years ago. Engaging mainly in basic research, he is focused on fluorescent metal organic compounds and their application in organic light-emitting diode, or OLED.
呢啲金屬化合物咧就可以用喺啲光催化度啦，用嚟做催化劑啦。另外就可以用喺發光物料啦。譬如可以用嚟做 OLED 咁啦。我哋平時嘅工作咧就最主要嘅步驟就係合成化合物嘅配體，需要好多呼吸嘅過程啊、純化嘅過程啊，跟住就可以得到嗰隻發光嘅有機金屬化合物。
Photocatalysis is the catalytic conversion of light energy to chemical energy. The most well-known example is photosynthesis in plants, where plants synthesize carbohydrates from carbon dioxide, water, or hydrogen sulfide with the help of light energy. Photocatalysts are chemical substances with catalytic properties when exposed to light. They are the agent for energy conversion. Many current studies on photocatalysis use titanium dioxide as the catalyst. However, it only absorbs UV light and does not fully utilize the visible spectrum of sunlight. To take full advantage of visible sunlight, new catalysts must be developed. Chi Ming has been cultivating new gold and palladium phosphate photochemicals for use as photocatalysts. These chemicals can absorb and utilize the visible spectrum of sunlight. They also have a prolonged and high-energy excited state, which corresponds to a quantum state that is at a higher energy level than the chemical's ground state. Generally, the excited state of metal organic compounds as photocatalysts would only last a matter of microseconds, but the metal organic compounds designed by Chi Ming have lifetimes of a few hundred or even 1,000 microseconds. That is hundreds to 1,000 times the typical durations, which translates to far greater photocatalytic efficiency. Here at HKU's chemistry laboratory, a 50-strong research team is conducting multiple chemical experiments. Joe is using platinum to develop fluorescent materials, while others are engaged in anti-cancer, Chinese medicine, and various basic studies. The architect and coordinator of all these is head and chair professor of HKU's Department of Chemistry, Chi Ming.
佢哋用嗰啲咩 host material， 你 brief 俾我睇，佢知道應該呢個 EQ 幾㗎呢個？
認識個數長冇記得。
佢點解佢唔 stable 咧？過來，真的，所以你沒有碰及去做，你沒有做過紅光？
我做過。
那個做得怎麼樣？
他們做得不好，只有大概5%。
嚇？你做過這麼多的 PT 的 command 的 device，你真正是覺得是這樣嗎？
是。
啊，這樣。我點都唔信呢個會得5%啦，
仲差過。
除非呢個 data 係錯嘅啫。如果淨係咁睇個 solution，冇去睇清楚，咁就 miss 咗呢個，以為玩完咗唔玩啦。咁而家睇50%，咁你估咧？咁即係講起其實世界上好多時有啲嘢，你以為嘅咧，其實咁可能你已經做咗。你同我準備有嗰啲資料關於當時咧嗰陣，唔係嗰啲我頭先所講嗰啲嘢啦。
頭先同支教授喺間房又傾咗一陣，晏晝佢會去做簡報嘅內容，跟住佢睇到啲簡報資料之後咧，忽然靈機一觸，諗起可以點樣改良嗰啲化學結構啊，嗰個襟棚嘅結構，同埋睇下嗰個器件可以點樣做得好啲。支教授係一個好嚴謹嘅人啦，同埋佢問啲問題都好尖鋭嘅。佢想知道一啲 data 咧，可能就想你即刻噏到出嚟。咁你知可能啲 data 你處理過咁多，一時唔記得咗啊嘛，係。支教授敬畏咯，唔係話驚嘅，係都尊敬嘅，唔係幾驚。
Joe and Chi have to catch an interview for the Innovation and Technology Fund. Scientific research conducted in Hong Kong often requires the application of such funds. He's applying to study the application of fluorescent platinum compounds in OLEDs. Born 1957 in Hong Kong, Chi Ming is one of the baby boomers. Capitalists who moved to Hong Kong post-war brought money and technology and over time contributed to Hong Kong's prosperity. Chi grew up in the 1960s and 70s, where competition in Hong Kong was fierce amidst a population surge. He grew up in a poor family of 6 and had to take up work after class to help. He went to a secondary school that was home to plenty of fights. Whereas many students scored 0 in both schoolwork and conduct, Chi managed to get into the Faculty of Science in HKU with stunning results. In 1992, Chi Ming became the youngest chair professor ever in HKU history at the age of 35. He was also the first Hong Kong scientist to be elected academician of the Chinese Academy of Sciences. In 2007, he won the first-class prize of the State Natural Science Award, an accolade often dubbed the Chinese Nobel Prize. Chi was also elected a Foreign Associate of the US National Academy of Sciences and founding member and Vice President of the Academy of Sciences of Hong Kong. Despite his academic excellence, he didn't do so well in chemistry experiments.
讀化學啊，咁你繼續做實驗啦，係咪？我做實驗就做得最慢嗰一個嘅，唔 efficient 啦。我啲同學做得好鬼乾淨，做實驗又好整齊啦，又快手啦。我就唔係，通常都做到成 overtime。第一年咁，我成日同啲先生傾偈，我同啲先生都好好傾嘅，唔係好似而家啲學生咁，成日都唔問先生。咁你梗係揀數學啦，咁你又考得 A 啦，即係科你都考到 A 啦，咁點解你唔話？不過我唔係，我讀化學嚇，咁讀化學咁你好似唔係好啱喎，咁你做實驗又咁樣，你做得好快好易 efficient 咁，呢個係啱嘅。但係嗰個化學反應會唔會產生嗰一樣嘢咧？唔係你手勢決定啊嘛，係你點樣設計個化學反應決定啊嘛。如果呢個化學反應根本就係冇可能做得到嗰啲嘢嘅，無論你手勢係神仙都好，你都變唔出樣出嚟㗎啦。
Performing an experiment is like cooking. Whether your dish carries the taste of meat depends on your ingredients. If you use stones as your ingredients, your dish will certainly not taste like meat. Meanwhile, if you have a piece of meat but fail to do it properly, things would end in a mess. In any chemical experiment, yield and the ability to separate different chemical products would depend on skill and technique. But the presence of a chemical reaction does not only depend on skill and technique. Chemical reactions are carefully designed to facilitate the experiments. Chang Gang joined Qi's team 7 years ago. He's studying organic light-emitting devices.
其实我不是化学系毕业的，我是电子工程那边的。这个器件呢，它本身是一个交叉学科，里边有物理、化学，包括电子工程，还有材料，各个领域的科学家合作才能够做出这种东西来。基本上来讲呢，就是用金属配合物作为发光材料来实现一个电致发光的器件。因为这个材料呢，它本身是不能够直接发光的，所以我们要通过一些电极、一些辅助性的材料，把它做成一个器件。那么本身这个器件呢，我们希望它又轻又薄，比现在所有的发光器件都好。那么就需要成为一种一层一层的薄膜结构。那这个薄膜结构就需要用一些真空啊，或者说是一些比较先进的实验手段和工艺来实现。一般是在可见光的范围，有红、绿、蓝或者白光。当然，现在还有最新的红外发光。
Qi published the world's first paper in 1998 on the use of metal organic compounds as phosphorescent materials, which prompted the development of OLED. OLED, or Organic Light-Emitting Diode, is a solid-state device consisting of thin films of organic molecules that emit light upon application of a voltage. In the 1990s, scientists came up with a way to produce phosphorescent materials for OLEDs with iridium. Despite its maturity, the technique comes with hefty patent fees. Therefore, the choice of chemical compound for the emissive layer holds the key to the cost of producing OLED. Today, an agreement is signed between HKU and the Sichuan province to develop multiple research projects. The organic phosphorescent materials developed by Chi Ming and HKU can potentially be applied to industrial uses, or what he calls making chemistry a reality.
One of my bright stars.
你上次同我講嗰個 cancer 嗰啲點啫？而家你做成？
我哋時間不如我俾個 presentation 你聽。
好啊。
Number 26 in the world in the latest QS World University ranking.
The signing ceremony is witnessed by the HKU Vice-Chancellor and Sichuan Governor. Chi Ming's team will receive $3 million of research funding annually for a period of 5 years, while Chi would become consultant of a Sichuan-based research company. This means both places will work hand in hand to develop OLED and the required talents.
因為四川係全中國嘅 OLED 嘅重鎮將來，而 OLED 係中國13規劃係一個重點發展嘅。咁全中國所有嘅 production line 啊，都會喺四川嗰度成立，即係做 OLED 嘅。唔係咁容易有呢啲嘅公司，有人唔願意俾錢你做嗰啲嘢，咁但係係指定做啲乜嘢，唔會話係無條件俾你做科研。 只可以咁樣做，只可以係嗰啲政府科研機構先會咁做。但係你香港嘅一個 research 班 council 一個嘅 project 大概嘅60-70萬度啦，平均係3年。你可以攞一啲好大嘅 project， 嗰啲好競爭好大，可能2年先至有一次咁樣去申請，但係可能你攞幾千萬，但可能幾個團隊、5-6個團隊。
你知每一間大學咧，一定有幾個 特別出色嘅研究員，特別優秀嘅研究項目係世界性嘅，可以話一流嘅。支教授係屬於嗰類，所以我哋好重視佢嘅研究。其實支教授嘅研究咧，我哋港大得益咗好多。 你去歐洲嘅地方，你去美國地方，去澳洲又好，日本又好，中國大陸又好，有啲人咧對香港大學嘅認識唔係好深。如果你問佢咧，你有咩香港大學嘅嘢你哋欣賞啊？佢講係，我知道係支持明，呢啲我哋叫 star 咯。中國發展得好快，朱教授咧，佢覺得四川有好大嘅潛力。佢嗰份材料嘅研究咧，再發展多一步咧，其實可以幫四川好大忙，能夠有機會同省級嘅人合作，人才培養，再加埋喺香港發展嘅科學做工業咧，我覺得特別重要。其實未來咧唔係淨係學術嘅研究，未來係點樣將學術研究帶俾社會啊嘛，帶俾世界，帶俾工業啊，呢個係我哋嘅願望嚟㗎。
覺得將 chemistry become reality 先能夠真係演繹到睇到化學嘅個重要性啦。而我相信化學係好重要嘅，但係化學嘅重要性唔係淨係話你自己識做化學，你要涉獵多一啲嘅其他嘅領域，譬如係材料科學啦、物理學啦，同埋係生命科學。你要去睇第二個世界嘅嘢，咁你先知道你要合成一啲乜嘢嘅化合物，能夠對另外一個世界嘅科學有啲貢獻。舉個例啦，你想做一啲嘅合成化學喺工業上應係完全零污染嘅，真係做唔係咁容易做。
A group of researchers in Shanghai are conducting research along the path of Chi Ming's work. Overseeing the laboratory is his former doctoral student, Xu Jianjiang.
Sure. 永恒，我们再说一下那个就是这个铁催化的这个工作，因为从你汇报的那个工作数据来看的话，现在做的这个效果是非常好的，但是因为我们做的那个量呢还是比较小的，那我想我们应该再做一个放大量的实验，比如说把这个原料的量增加到5克到10克。
那个催化剂的量是，因为以前我是用5%的话，我现在是降低到多少？
现在能不能看看能不能够降到1%或者是更低？如果低了以后呢，效果也还是一样的话呢，那这个方法就变得非常实用了。我们现在想做的工作呢，就是把支先生制备得到的这些催化剂呢，发展出一些非常高效的这个催化体系。那么我们想做的事情呢，就是在这个理念下面呢，用一些就是没有毒性或者是污染很小的这个办法来实现这些化合物的这个生产。那么我们希望我们在实验室里面开发出来的这些方法呢，能够在将来呢得到广泛的应用，真正的让大家发现，哎呀，化学原来是绿色的，对我们大家只有好处没有坏处。
The Shanghai-Hong Kong Joint Laboratory in Chemical Synthesis was jointly established by CUHK, HKU, and the Shanghai Institute of Organic Chemistry of the Chinese Academy of Sciences, CAS. SIOC was founded in 1950 as one of the first 15 institutes established by CAS. It is an integrated chemistry institute that engages in basic research, applied research, and development of advanced technologies. Ding Koi-ling has known Chi Ming for more than 25 years, and he still remembers the first time they met.
第一次认识支先生，在京都的时候，93年，就是国际配位化学会议，30几岁的一个年轻的科学家去做 plenary lecture， 这种大会上，一般4到5天的会议，只有5到6个 plenary lecture， 而且支先生他对年轻人、对他的学生的培养，这个是很多科学家里面不常见的。
Chi Chi Ming caught a heavy flu, but he still came to the joint laboratory to check experimental progress and follow up on his students, providing them with research pointers.
怎么样？你做2个多月了，是不是？
嗯，快2个月。
你快2个月去做这个的事情，你希望做这个东西来做什么的事情？
这个想着就是。
以前大個就過嚟一次度，之後再嚟到呢度，咁我就唔走㗎啦。咁見下啲學生啦，聽下啲 presentation 啊，佢哋嚟同我傾啦，咁嚟傾下嗰啲嘢，討論下嗰啲嘢。我又唔知點解會做到咁啊！但係咁多年都係咁，都唔係咧，即係條命生成咧，就命苦喎，要做好多嘢。
已經跳出化學家的範圍，是吧？就是
沒什麼回應，我只是那個工作嘛，工作沒什麼化學家跟科學家，工作嘛。
我們在這都不會，我們只是做一件事情。所以剛剛講了有機、無機。 它是有機、無機、生物、生化，一直到 drug design。
那我是 lucky， 有人願意給錢給我，有人願意給錢給我去做，沒辦法了。
我也想沒辦法，我多一點錢。
我雖然我喺有機所嗰度嗰啲學生就唔係好多，但係都有幾樣嘢好重要嘅研究做咗出嚟。特別係最近用鐵嘅化合物做催化，我哋叫做 asymmetric cis alkane dihydroxylation reaction 啦。咁呢個反應用鐵用雙氧水做氧化劑，咁比起 Sorbus reagent 效果會十分之好啦。Sorbus 就係諾貝爾化學家嚟嘅。 佢攞諾貝爾獎就係都係因呢一樣嘅反應，但係佢哋係用 osmium tetroxide 做催化劑。咁 osmium tetroxide 係好毒嘅，工業上亦好難用。咁如果用鐵能夠做到 osmium 嗰個效果會十分之好啦。因為我哋最終希望能夠工業上咧就唔用 noble metal catalyst， 就希望用earth abundant metal， 特別係鐵啦，因為鐵係嗰個喺 earth planet 嗰個 abundance 好大嘅。 而且鐵嗰個對嗰個 biocompatibility 係最好，因為人體係有鐵啊嘛，所以就希望發展鐵催化嘅反應。
Osmium tetroxide contains the highly toxic element of osmium. It has the highest density and is the rarest stable element in the Earth's crust. Osmium tetroxide is highly volatile and penetrates the skin easily. Low concentrations of osmium tetroxide in the air can lead to pulmonary congestion and damage to the skin or eyes. It is extremely dangerous. On the other hand, iron is the second most abundant metal in our planet and is non-toxic. If iron-catalyzed reactions can be applied to industrial uses, we can drastically reduce production costs and environmental pollution, thus promoting green and sustainable synthetic chemistry.
君謀係汪柔教授嗰個別號啊嘛，佢個君謀樓呢個係紀念佢一代化學家對個有機化學嘅貢獻啊嘛。你淨係香港淨係識啊，有啲喺外國翻嚟喺外國攞諾貝爾獎嘅，翻嚟就擺喺度就黐人哋個名喺處。香港人最中意就係咁樣啦，又話香港出身啦，喺外國讀書攞咗諾貝爾獎翻嚟。咁呢個就好明顯睇見中國喺呢方面對科學家係尊重嘅。 即係相對嚟講，香港應該有一個化學嘅研究所啦。如果一個香港化學嘅研究所就集中喺香港一啲好叻嘅科學家，咁自然你嘅高科技同化學有相關嘅係會延伸出嚟啦。所以你咪睇下呢個係一個市中心，市中心你見有冇味道咧？
冇味道啊，係咪啊？會唔會臭咧？都唔會臭啦，係咪？你都見到呢一樣嘢，咁香港會唔會做咧？
To recognize top Asian scientists, the Asian Chemical Editorial Society and Ryoji Noori, winner of a Nobel Prize in Chemistry, joined hands to create an award which was first presented in Melbourne in 2017.
This time is the first occasion to give an award. The first recipient is the Professor Chi-Min Che from Hong Kong. Not only publication, what he has done in chemistry is amazing because his interest or his research area is so broad in scope. Still, I don't know which one is his major one. He will give a talk after this one, so he will show it to us. To you, congratulations.
Thank you.
He always aimed for the higher efficiency and the green type chemistry, minimize the energy to be consumed and minimize the waste from the reaction. And that kind of idea is very good. Particularly, it gives a very good influence to his students.
When I say Professor Noori, I think he makes, from my point of view, to make chemistry to become reality.
So I was fascinated by Chi-Min Che, that he has such a wide range, starting from this so-called bioinorganic materials to using catalysts for making chemical compounds that are used in the pharmaceutical industry or in the perfume industry. He centered around metals in the first place, and metals are part of the enzymes in the human body, and that's where he started out, to be a so-called bioinorganic chemist. To the point that he also developed metal compounds that can be used as therapeutics, as anti-cancer reagents.
Chi feels that chemical research should ultimately help improve lives and the Earth's environment. Achieving this requires studies from different angles. His expertise was in organic chemistry, but he has started to branch out.
我最近係好着重喺化學嘅跨領域嘅研究。自從2003年開始，我就開始研究化學喺個生命科學、個醫學嗰一方面嗰個應用啦。醫癌病嘅點解化療咁痛苦咧？因為化療嘅帶嚟嘅副作用好大。金嘅抗癌佢嘅效果咧係好有效，但係好鬼死毒。佢唔止將個腫瘤減少得好犀利。 連個 animal 都殺死埋，所以根本冇人會去用啊，因為太毒啦。因為咁我又咁樣開始咁諗，其實人對金嗰個係咪真係咁敏感咧？好多人都戴金戒指啊、金頸鏈啊，咁或多或少人類跟同金嘅接觸咧，梗會有啲嘅。咁一定會有微量嘅金進入人體嘅，所以其實少量嘅微量嘅金對人嗰個，我諗係人嘅。 即係可以能夠承受得起嘅，咁我就開始對個金嘅研究，係基於呢個嘅概念去咁做，即係新嘅抗癌。
Among the cancer drugs for chemotherapy, platinum-based metallic agents are common, though they also carry many side effects. Chi's team utilised their expertise in metallic compound research to develop multiple anti-cancer metallic compounds, winning global recognition and accolades. The team used chemical techniques to develop pilot drugs that are more effective and have fewer side effects than the current platinum-based chemo drugs. They're now working on the preliminary study on clinical application.
我就有呢個比較，你或者可能係嗰啲嘅 crazy 嘅諗法啦，有啲嘅，我又覺得世界上可唔可以有啲冇毒嘅藥啦，又可以醫治癌病啊？咁最好啦，係咪？ 最好食嗰啲嘢冇毒嘅，好似話如果真係有癌病，咁食咗落去， 咁可以慢慢咁，就算可以變得佢可以長期病嘅，可以食藥，可以即係等於你 Panadol 頭痛嘅。咁我諗好多癌病嘅人其實做到最收尾咧，即係做咗手術、做完電療、做完化療，唔多唔少佢都走去睇中醫嘅。咁我話我可唔可以喺從中藥嗰度方面尋找一啲非毒性嘅嘢係可以抗癌咧？
From inorganic to organic chemistry and on to chemical biology, Qi owns an ever-increasing number of interdisciplinary research projects, and his teams also get bigger and bigger. Fu Zhuowen is one of the researchers on anti-cancer TCM and a doctoral student of Qi-Ming.
因为对于中医药来说，有个很大的问题，首先它的成分种类很多。 然后成分种类很多，还有个问题，各个成分种类的 abundant 的就是量特别少，因为我们要去找到中药里面有 effect 的物质是哪一个，所以我们要克服2个问题，一来去怎么拿到这些 abundant 特别低的一些 constituent， 然后这是第一个很大的一个摆到我面前的困难，然后还有一个困难就是说，我们怎么去确定在那么多的constituent 里面找到 真正有 effect 的一个 compound。
Practitioners combine different medicinals based on unique TCM theories to create compound formulas. But the varieties and combinations of TCM make it very difficult to study their chemical and bioactivity and promote them in global markets. If you don't find out about the constituents, you would not understand the medicine. Thus, Qi decided to look at specific compounds to determine their chemical and bioactivity. Enhancement of naturally bioactive compounds in Chinese medicine through the synthesis of new derivatives and chemical reformations is key to the development of medicines. The team discovered that the medicinal thymosaponin extracted from the Anna marina rhizome can induce the death of cancer cells. Research is like a detective case. Every cell is protected by a mysterious lock, including cancer cells. To kill a cancer cell, we must first locate its lock. In pharmacology, this is called a drug target. Once you find that lock, you would of course need the right key. Each drug is like a key. Another mission for Qi's team is to study the characteristics of each key. Obviously, the right key would unlock the cancer cell and destroy it. But things are not that simple. Often, a key does not only unlock cancer cells, but also normal cells, destroying them too. This is what we call side effects. To minimize a drug's side effects, the research team has to improve the key so that it will only unlock cancer cells, but not normal cells. Even when cancer cells are destroyed, the case does not end there. We must still look into the cell's cause, manner, and time of death. We need to see how a drug kills cancer cells and how it can be improved to avoid instances where the operation was successful, but the patient died. That means chemists must constantly improve the combination of these compounds. The design and study of these compounds is the expertise of Qi-Ming and his team. Researchers must always be curious. Here, Phoenix plays host to a major international conference where scientists from around the world gather to exchange their insights.
我今次我哋Phoenix 係開嗰個 MRS 嘅會啊，係美國一個好大型嘅會議嘅。MRS 係一個嘅學術嘅組織，關於材料嘅研究啦。 包含個領域有化學啦、物理啦、工程啦，同埋係醫學嘅，而係涵蓋有嗰個 basic science 同埋 engineering 嘅。其實一個社會唔係淨係靠一個人㗎嘛，要生生不息㗎嘛，要好似有機所咁樣，都唔係淨係靠一代嘅科學家，有一代有下一代，係咁循環不息㗎嘛。You can do the down conversion。有得着㗎，因為你可以聽多啲唔同嘅領域啦。 即係當然你有咁樣嘅 energy 你就可以啦 ，refresh 你自己嗰個 memory 啊，或者你嗰個諗嘢嘅模式啊，原來呢個世界上我認為可能唔得嘅嘢，原來已經有好多人做緊㗎喎已經。咁呢樣嘢都係好緊要，因為人通常你唔係真係話叻到咁緊要啦，你可以乜都諗晒啦。你諗呢個世界改變嘅速度比你想象中更加之快咯。你以前教緊啲人點樣去冚一部計數機，當原來全世界嗰陣時已經到地方已經好成熟，做緊第二樣嘢嗰陣時候，咁你教埋個班後生仔淨係識計就識冚個計數機，咁我出嚟佢點揾食咧？以前人冇諗住嘅做唱片會執嘅會，即係就喺大學教書就要 update 你自己嘅 knowledge。因為你教下一代，好辛苦嘅坐飛機。冇乜必要，我就係唔想坐飛機。但係諷刺就係我又要成日要去開會啦，所以又要成日坐飛機。雖然我應該係去咗外國嘅所謂叫做出 trip 啦，以前就手機冇咁緊要，又冇咁流行嘅，就算想做嘢都唔係咁容易做咯。喺50年、60年嗰個人類嘅科學文明進步得好犀利，遠超過以前嘅幾百年啊，甚至上千年嘅進步，會消耗咗好多嘅資源啊。咁人嘅腦係咪真係咁聰明，可以能夠你同時咁進步，但係容易能夠 restore 翻嚟？咁呢一樣嘢係唔知咯。我自細讀化學，其實一個原因我中意化學嘅，我就好中意一個科學家叫 Linus Pauling， 佢寫一本書叫《Nature of Chemical Bond》。咁 Linus Pauling 係加州理工嘅教授，諾貝爾得獎，係上世紀好偉大嘅化學家。咁我個導師 Harry Gray 著名亦係喺個 Chemical Bonding 化學電力論讀預科嗰陣時，我都有睇佢嘅書。咁我覺得我應該要去見下呢個人啦。
Hey, man, how are you? Chemist, how are you? It's good to see you after all these years, my friend. Way to go. It's good to see you. It's good to see you. You look great, too.
Okay, I'm okay.
After completing his PhD thesis at HKU, G felt it was time to continue abroad. At the recommendation of Professor Poon Chun Kwong, he went to the California Institute of Technology, where he engaged in postdoctoral research with Harry Gray. They were associates and companions who boast more than 30 years of friendship.
Work on the Corona.
And I bet that it will.
Okay, I hope it does. Cheers. 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 I think you have the explanation.
Yeah.
I think I figured it out, Chi-Ming. He's brilliant. He's my most brilliant student. Chi-Ming Chi. He started in my lab. He's a fantastic guy. Knows everything. Can make any compound you want. Explains everything. And he's become super famous worldwide. Everybody knows him, and so you should be very proud of him in Hong Kong.
So you
very proud.
So you like it?
Okay.
So you like his hypothesis, right?
Yeah, I like it. I like it a lot.
咁我就申請好多度地方嘅學校啦，劍橋大學啊、Princeton 啊，佢哋都收我。最將我選擇去加州理工。加州理工不嬲都係我好中意嘅學校，亦係啲人所謂嘅天才學校啦。
He's an expert in many things that I am not, and I'm an expert in some things that he can still probably learn a few things from me. I'm not sure whether he now knows so much. I'm not sure there's anything left he can learn from me, but maybe something. Well, Professor Chi has made a new gold compound, never before existed on planet Earth because it's a new composition of matter. He's shown this gold compound is a very powerful anti-cancer agent, and that's extremely important. If you're making new compounds, there's no telling what they might do. They could do anything. They could be catalysts, they could be anti-cancer, they could be anti-diabetes. And so that's why making new compounds is the most important thing in chemistry, because no telling what's going to happen with them. They could revolutionize medicine.
Should be here.
I think my really creative mind in doing science was in 1980 to 1990. At that time, I did not have a lot of resources in Hong Kong. You know, since the year 2000, I had a lot of resources. I have more publication.
Yeah.
But I do not think the level of impact coupled with my resources in a proportional manner.
I see.
So I thought that maybe my research was not creative enough. So I thought about this. So I want to go back to my old days.
Really? Interesting. That's very interesting.
So I thought about how I behave.
In the old days?
In the old days. So I start to go back to the young age. I just had the feeling that my golden age started.咁我中意加州理工，咁所以我83年至到90年嗰段時間成日嚟加州理工嘅。我覺得今次都係一個好嘅時間，我翻嚟加州理工。我有10年好似冇翻過加州理工。咁我咪話佢聽我黃金時間開始啦。咁我要 go back to 我去翻我以前個年代啊嘛。我以前個年代就係加州理工啊嘛，所以咪翻嚟加州理工，找尋翻我以前嗰個黃金時間。都好自然咁嚟到呢度，咁我覺得呢度嗰個心好寧靜嘅。我想同你講，做科研一個好緊要咧，做科學工作就係你個心唔夠唔安定。你成日嗰個心好唔安定嘅話，其實係做唔到嘢嘅，做唔到好嘅研究。你諗下，我80年代，我個科研基金唔係咁多，咁我個唯一嘅好處係咩嘢啦？我點解做到咁多好嘅科學啦？但係嗰陣時嗰個心境係好寧靜。
On the 22nd of April 2017, over 1 million people from 600-odd cities joined a rally called March for Science, which hoped to reinstate the value of science.
Keep to remind 個社會 science 係好重要。咁有啲嘢就算你知道，你都講多啲。佢想教育下一代，你要記住都仍係要喺呢個社會一定要做多，一定要有做科學啊，科學嘅重要性。喺一個社會，如果冇咗個科學個教學同埋個研究其實係好危險啊。
It's also important to us. Because we're home to Caltech, science is really baked into the culture of this city. Science, after all, promotes the search for objective truth. We desperately need that truth.
政府其實係有一個好重要嘅責任啦，但係呢個社會都好重要啊嘛。呢個社會都唔係好支持，咁點解社會唔係好支持咧？咁有可能社會唔知道啦。唔知道咁重要，或者個社會又唔知道點樣去支持，所以有呢啲咁樣嘅遊行都係好重要啦。因為政府通常都會聽下啲人普通啲人點樣諗嘢嘅。我唔相信香港嗰啲嘅一般嘅社會覺得 science and technology 真係咁重要。 如果佢真係覺得咁重要嘅話，對香港佢哋應該會出多啲聲嘅，應該係咪？又或者佢哋知道呢啲樣嘢，但係佢覺得佢哋可能知道 science and technology 係好重要，但係佢哋覺得喺香港唔係咁重要。譬如運動員都有陣時都要出嚟講，叫政府支持體育嘅發展。你都成日都會間中都會聽到呢啲嘢啦。即係嗰啲藝術工作者都會有出嚟去講一啲關於嘅，但係你真係冇見過有做科學工作者出嚟話大家嚟有一個遊行話係要支持科學啊，支持性。咁點解咧？咁呢個係咁你又香港又話要搞咁多高科技啊，又話搞咁多。Hi, how are you?
What are you doing here?
Hi, fine.
Hi, Ed. Welcome to Pasadena.
Yeah,
Welcome
hi,
home.
John. How are you?
Very well. How are you? I didn't know you were coming.
Yeah, I'm coming. I'm going to see Harry.
Yeah. Is he going to be here?
No. I'm going to see him. Yeah. So you come here to support science?
Yeah, I do. Yeah.
That's just to support your iron chemistry.
Yeah, exactly.
All top scholars and
On Chi Chi Ming's 60th birthday, HKU's Department of Chemistry organised a seminar on inorganic chemistry, where a number of world-famous chemistry professors spoke.
其實我哋不嬲都搞好多 conference symposium 去做呢啲我哋叫功能分子材料，尤其是係金屬配合物嘅。學術界咧好多時搞 conference 就唔係話即係淨係想大家聯繫下，咁其實就係想聽下大家有啲咩新嘅研究方向啊，大家互相去即係刺激大家去諗下有啲更好嘅嘢。啲教授啊，或者一啲科研者啊，60啊、70啊，或者甚至80生日嘅時候，會啱啱同一時間有個 symposium 咧。其實呢個係全世界好普遍嘅，因為我哋都希望即係 pay tribute to 一啲作出好大貢獻嘅一啲科學家咯。
Scientists take single oxygen which will kill cancer cells by various mechanisms.
What impresses me most about the science that he's doing, interdisciplinarity, because he's not only synthesizing new compounds, which he's actually very good at, and that's where some of his roots are, but he's learning how those compounds work in cells and in models of cancer. And his papers cover the breadth of chemistry, biology, and medicine, and physics, the techniques, and so on.
Very efficient.
这么年轻的情况下，他就已经得到了中国科学院的院士，这个在国内当时是非常大的一个影响。所以我也是带着这样的好奇，这么年轻的人做了什么样的工作，可以做得这么好？所以在这里呢，非常受支先生的这个启发。所以这么多年以来，我也在这个领域里就做下来了。
He could see a molecule like Mozart could see a concert or some music, or Monet could see a painting. Professor Shi could see a molecule that nobody had ever thought of before and then make it and create it.
New fields. So what I'm like to say is, I will tell you what I'm doing. Maybe 5 years time, and then I will tell you my golden age in chemistry. Thank you very much. 我唔知我最中意係乜嘢啦，可能我未有揾到我最中意嘅嘢。總之唔爭，唔係一定要做最中意先會做。如果你做某一樣嘢都要 expect 好多 return 嘅話，其實好辛苦嘅。咁你人生會世事無常啊嘛，係咪？我唔會好似你哋咁諗得咁遠嘅。咁我話我一個黃金時間開始，咁我會盡量做好。 咁我希望做好，咁做得好唔好唔知㗎。